All right, so on this day 3, we're going to pick up where we left off last week, and we're still going to be focusing on this goal. We're going to be writing an equation of a line and its slope and a point and a line, but we're going to focus this time on 2 special cases, parallel and perpendicular lines. What do we know about parallel lines? So let's chat real quick. Parallel lines, here's the shortcut. Instead of writing the words parallel, you could always just do this. I tend to write it as slanted 11. Perpendicular, you can write it pretty fast just by an upside down capital T. That just means perpendicular. So instead of writing the words out, feel free to use those. If you were to sketch them real quick, and I'll do so in the characteristics box, parallel lines, and it doesn't ever matter what's their orientation, just as long as they're not intersecting. The key thing about that is this little chicken foot / triangle tells me that they are parallel, even if it doesn't look it. If somebody writes this symbol here and this symbol here, then that means that they are parallel. In the same way over here, if I have this puppy here and I draw perpendicular, even if it doesn't look perpendicular, if this little box is drawn, the lines are perpendicular. So that's characteristics in a graphical way. But here's the key about parallel lines. Parallel lines, and generally we can write them as something like this: y equals m1 times x plus b1. I'll explain that momentarily. My second line is m2. In other words, a different slope, and here's a different b. Now it turns out we're going to use exactly this over here as well, so I'm not going to write it again. I'm just going to dissect each of these, what these letters mean per case here. So for parallel lines, the key thing about parallel lines is that they never do what? They never intersect on a plane. So if I had a line that was going in this direction, and it would go up a certain amount and right a certain amount, then this line down here, it would go up the same amount and right the same amount so that it would never intersect, kind of like chasing each other, right? Well, what is going up and right mean? That's slope. So what can I say about the slopes of parallel lines? The slopes are the same. That's the key of parallel lines. Slopes are the same. Slopes are the same, or same slopes for parallel lines. Now, what's also key is not only are the slopes the same, but their b's are different. B1 can never, ever equal B2. They cannot have the same y-intercept. Perpendicular lines are going to sound more complicated. Not only do the m's not equal, they're clearly not going to be equal to each other. They have another special relationship. So perpendicular lines, their slopes look like this. One way to describe it is that the product of the slopes is -1. And you're like, what? So if you take one slope and you multiply it by the other one, you get -1. Another way to write it would be like this, is that one slope is the opposite reciprocal of the other one. Opposite reciprocal. So that's where we're going to focus on. We're going to practice that in just a minute. Please go ahead and take a moment to write this down, that they are opposite reciprocals. Opposite reciprocals. So for example, if one of your m, let's say m1, was 2/3, that would mean your other slope is the opposite. So instead of positive, it's negative. And instead of 2/3, it's 3/2. So you take the opposite from positive to negative or from negative to positive. Doesn't matter, as long as it's the opposite. And you take the fraction and you flip it. So these two right here would be the slopes of perpendicular lines. These are the slopes of perpendicular lines. Let's just do one more. What if I'm given the slope is equal to -2? What's the opposite reciprocal of that? Good. Positive 1/2. Again, we have to flip this. Remember that there's a 1 underneath, and we make it positive because it started out as a negative. Now, let's take this information and look at example number 5. What is the equation of a line that is parallel to y equals 6x minus 2 and passes through this point 1, negative 3? Second part, what is the equation of a line that is perpendicular to y equals 6x minus 2 and passes through, oh look, the same point? So the first thing we want to observe is that part A is asking us to look at a parallel line, and part B is asking for a perpendicular line. So you don't have to sketch this out, but just to give you a perspective, 6x minus 2 is something like this, where it's a very steep slope, like so, and crosses low at the negative 2. This is just a sketch. So what we're asked to do is to go to 1, negative 3, somewhere down here, and we're trying to find a parallel line to that. And at that same point, we're trying to find the perpendicular here. So those are the two things we're going to look for. So part A, and I'm going to label it A even though it wasn't labeled A, is I want to talk about the parallel line. So what's the key thing about parallel lines that we just looked at? Is that with parallel lines, my slopes have to be exactly the same. So what's my reference slope? This is the one that I'm dealing with, the 6x minus 2. So I know that my slope is going to be the slope given to me. It's just the slope of the other line, the 6 right there. Now, we are given also a point, and that is very helpful. Because since I am effectively given the point, the slope 6 and the point 1, negative 3, I now can use point slope form. So just to get myself memorized, I'm going to write point slope form down. And then I'm just going to start to substitute y minus my negative 3 equals my slope, which I discovered was 6, times x minus 1. And now I simplify where I can, and I end up getting y plus 3 equals 6 times x minus 1. And this is sufficient because it doesn't say what form to leave this, so make sure that's a 3, and I'm going to circle this and say that's my result. Now, along the same path, we're going to find out what the perpendicular line is. And instead of the slopes being the same, the slopes have to be opposite reciprocal. So my original slope is 6. So I have to flip that and take the opposite. So the opposite is a negative, and the reciprocal is a 1/6. Now I do exactly what I did over here, but instead of using a 6, I'm going to use a negative 1/6. So effectively, I can jump to this right here and just replace the slope there. So y plus 3, why can I do that? Again, because I'm using the same point here, equals negative 1/6 times x minus 1. So the the equation of the line that is parallel is over here, and the equation of the line that is perpendicular is over here. Now the next part that you're going to look at is you're going to practice those two on number 17 and 18, being very aware that this says parallel, so you have to recall, how do I find the slope here? And downstairs, perpendicular, so what's the slope from here? And then we can just substitute it into point slope form and simplify that. Good luck to you.